So, dear friends, once again welcome. Now let's discuss about basing the design on task requirements. So, means we want to talk about what is the base of the manipulator based on the task requirements, and it is part of manipulator mechanism design. So, although robots are nominally universally programmable, okay, that's why it is not a hard automation. Okay, it is programmable automation. Machines capable of performing a wide variety of tasks. So as per the definition, the multifunctional, it should be the multifunctional. Economics and the practicalities dictate that the different manipulators be designed for particular types of task. Okay, so for different task, there may be different robots. One robot may not be sufficient for all kind of task. Okay, now let's talk about example. Large robots capable of handling payloads of 100 of pounds do not generally have the capability to insert electronic components into circuit boards. Okay, सो हियर करने का मतलब क्या है कि भारी भरकम जो ज़्यादा लोड कैरी कर सकता है, अब उसको हम छोटा सा टास्क फॉर द इलेक्ट्रॉनिक्स बोर्ड वी नीड रोबोट नीड टू इंसर्ट द वेरी फ्रेजाइल पार्ट्स इन द नैरो स्पेस, सो दैट इज नॉट पॉसिबल. Okay, and as we shall see, not only the size but the number of joints, the arrangement of the joints, and the types of the actuation, sensing, control will all vary greatly with the sort of task to be performed. Okay, so what we get, so not only the size but also the number of joints and how the joints are arranged, and types of actuation means we're talking about it may be electrical dependent DC motors, it may be mechanical, it may be hydraulic, and the sensing devices and the control. ठीक है, इस सब पे डिपेंड करता है. So now after that, the number of So, in connection with the basing the design on task requirements, now next is the number of degrees of freedom, DOF. So, the number of degrees of freedom in a manipulator should match the number of required tasks. Okay, so suppose we give number of degrees of freedom, this we denote by n, and the task number of task we denote by m. So what should be? M is equal to n. And what is the meaning of this? Suppose manipulation is required in the x, y, z direction, only translations are required. So 3 tasks means here m is equal to, now is equal to 3. So how many degrees of freedom required? N is equal to 3. So as per this it should match. Not all the tasks require full 6 degree of freedom. ठीक है, सो हम ऐसा डिजाइनिंग क्यों करें? दिस इज मीन्स अकॉर्डिंग टू 6 डिग्रीज ऑफ फ्रीडम, बिकॉज इससे क्या हो जाता है, स्ट्रक्चर बल्कि हो जाता है, मोर नंबर ऑफ एक्चुएटर्स रिक्वायर्ड, मोर नंबर ऑफ सेंसर्स रिक्वायर्ड, मोर मटेरियल्स, मनी, स्पेस रिक्वायर्ड. Okay, so that's why we need to avoid. Okay, and the next, the most common such circumstances occur when the end effector has an axis of symmetry. Okay, and below there are 2 figures you can see here. Below figure shows a manipulator positioning a grinding tool in 2 different ways. So let's talk about this. So आप देख सकते हैं, our focus is here. This is what? This is the tool. Similarly here, this is the tool. Okay, and what about this? Is the base of the robot, and two arms are there, this one, so arms means two arms, then what we get? Manipulator. Okay, and this is what? This is the gripper, or you can say the end effector. Okay, so what is going to be addressed here? See, the surface, the means the workpiece in which grinding is going to be done, and this is just the orientation of the tool. Similarly, this one here, and in both figure, see the orientation of the both the tools. Okay, so both are same, but the configuration here, from here you can see the configuration. You can compare configuration. ठीक है, ये configuration change है, but the tool orientation is same. Okay, so the tool axis of symmetry means the tool suppose rotates about its own axis. So is it required? Is it means is it needed? No, because there is nothing use of suppose a tool, grinding tool or some welding torque rotates about its own axis. ठीक है, और उसको कहीं एडजस्ट करने की जरूरत नहीं है कि कहीं ये कॉर्नर छूट गया, वो कॉर्नर छूट गया, क्योंकि सिमेट्रिक है, उसका जो ज्योमेट्री है सिमेट्रिक है टूल का. ठीक है, सो in that case, in this case, we can avoid 1 degree of freedom. Means what? So 6 degrees of freedom required for the X, Y, Z translation, and then the roll, pitch, yaw, roll, pitch, yaw. Okay, so roll is not required here. Okay, so this why not to understand this with the help of one very nice video I have. See here what is happening. देख सकते हैं the grinding wheel and robot hand effector. grinding wheel आप देख सकते हैं, अगर grinding wheel yeah, so suppose it rotates about its own axis. This is the tool, the grinding tool. It rotates about own axis, means own axis means about this. So is there any use? Separately it rotates, the grinding wheel rotates, and the axis also rotates. So is there any use? No. Okay, so in this way we can avoid 1 degree of freedom, that is the rotation of the tool itself about its own axis. Okay, now let's talk about, okay, so the same thing in this case, the orientation of the tool with respect to the axis of the tool itself is immaterial, because the grinding wheel is spinning at several hundred rpm. Okay, and to say that we can position this 6 degree of freedom robot in any, means in an infinity of ways for this task. We say that the robot is redundant for this task. Okay, arc welding, spot welding, deburring, gluing, and polishing provide other example of tasks that often imply the end effectors with at least one axis of symmetry. Okay, so in this way now we come to know that means all the 6 axes are not required. So to avoid that, why not to make, means why not to opt a symmetric tool, so that in the like in this case rotation itself that is not required. Okay, but still 5 degrees of freedom are there, and these are sufficient. So with this, thank you.